So, example 1, solve the system by adding. Solve the systems by using the elimination method. And what I see here in equation A and equation B has the additive inverse. That means that it's going to be the opposite sign. So opposite from a positive is a negative. We're going to look at these two specifically for the additive inverse. We're going to do our linear combination. That means that we're going to add going down. And let's start from the left. 2x plus 6x is 8x. Those are going to simplify, cancel out each other. And I have 17 minus 9, so I get 8. I'm solving for x. I'm going to divide both sides by 8. X equals 1. So we want to go ahead and solve for y. We're going to use the first equation, 2 times 1 plus 5y equals 17. 2 plus 5y equals 17, minus 2, 5y equals 15. Divide both sides by 5 because we want to get y by itself. Y equals 3. Our solution is going to be 1, 3. Remember, a solution is a point of intersection. Okay. Solve the systems of equations by elimination method. So let's go ahead and do this together. Solve the system using elimination method. I'm looking for the additive inverse. You see them? They go away. I'm going to add vertically, linear, from left to right or right to left. 5x plus 3x is 8x equals 32 plus 48 is 16. We want to solve for x. 8, divide both sides by 8, x equals 2. Now we're going to substitute back into equation A. Times 2 minus 6y equals negative 32. We're solving for y. 10 minus 6y equals negative 32. Minus 10, negative 6y equals negative 42. Y, divide by negative 6, divide by negative 6. Y equals 7. My solution is going to be 2, 7. That's a soft parentheses because this is an ordered pair. So, what if the variables don't eliminate just by adding? Well, this is what we're going to do. We're going to multiply 1 or both equations by a number that will allow a variable to disappear. So again, we are going to multiply one or both equations by a number that will allow a variable to disappear. So let's look at example 2. Solve a system by multiplying one equation. Solve the system by using elimination method. Of course, we want to make sure our x and y's and our numbers are aligned. And we want to create the additive inverse, or we want to make something disappear. we want to make this negative 5y disappear. So we're going to multiply the entire thing by 3. So equation A and equation B is going to be multiplied by 3. My new equation is going to be 21x minus 15y equals 51. I got this by multiplying 3 to each term in equation B. So this is my new equation B. I'm going to rewrite A right underneath it. Remember, it doesn't order. The order does not matter. Excuse me. We're going to add. We're going to have 19x equals 51 minus 32. 19. Solve for x. Divide both sides by 19. X equals 1. And the 15 disappeared. We're going to go back to equation B and substitute the x back into equation, back to equation A. Negative 2 times 1 plus 15y equals negative 32. Negative 2 plus 15y equals negative 32. Add 2 to both sides. 15y equals negative 30. Divide both sides by 15. Y equals negative 2. My solution is 1 comma negative 2. That is the point of intersection when graphed. Opposite signs. One is a negative, one's a positive. We're going to multiply equation A by 3. By 3. And we're going to distribute the 3 to each term and see what we get. So we get negative 15x minus 6y equals 12. Let's rewrite equation B. 3x plus 6y equals 6. We know that these are going to go away. Eliminate. Let's solve by adding vertically. 12 plus 8 is 18. Equal sign. Negative 15 plus 3 is negative 12. X. So that's negative 15x plus 3x. We want to solve for x, divide both sides by 12 or negative 12. X will become negative 1.5. We're going to take the x and substitute it back into equation A. Negative 5 times negative 1.5 minus 2y equals 4. We're trying to get y by itself. Negative 5 times negative 1.5 is 7.5. Rewriting the equation, minus 2y equals 4, minus 7.5, minus 7.5. The reason why I'm doing this is because I'm trying to get 2y by itself, or negative 2y by itself. So I have negative 2y equals negative 3.5. I want to get y by itself, divide both sides by negative 2. Y becomes 1.75. The ordered pair is negative 1.5 comma 1.75. Again, we got to use decimals. The solution is the point of intersection. Alright, example number 3. Solving a system by multiplying both equations. This will occur. We're going to do this in this example and the second example, and then you're going to have a worksheet to review the different methods that we've been learning in these videos. So, I do not have the additive inverse, but I'm pretty close. I think in this case I want to concentrate on the x's because they are both multiples of 12. So what I mean by multiple of 12, if I have 3x and I multiply that by 4, or excuse me, by negative 4, I'm going to get negative 12x. And then if I have 4x and I multiply it by 3, I'm going to get a 12x. And so with that in mind, both of those variables will be eliminated. Equation A, equation B, always want to do that. Multiplying both equations. Remember, the numbers are going to change. You're not always going to use 3 or 4. We have to create the equations for them to eliminate. So we have to look at the different factors available in each equation. So to simplify, equation A becomes negative 12x minus 8y equals negative 4. Equation B becomes 12x plus 9y equals negative 6. These numbers are distributed to be multiplied into each term for each equation. Remember, we're going to add vertically. I have negative 10 here equals y, and those get eliminated. So y equals negative 10. I can now substitute. Does not matter what equation we substitute in. So substitute into equation 1. 3x plus 2y equals 1. I'm substituting the y for negative 10. 3x plus 2 times negative 10 equals 1. 3x minus 20 equals 1. Add 20 to both sides. 3x equals 21. Divide both sides by 3. X equals 7. So, this is the x, that's the y. We're going to present them as an ordered pair, 7, negative 10. And that is my point of intersection and solution. Let's look at the last example. Solve the system using elimination. In this case, I would like to concentrate on the y's. Every time you multiply or you're trying to eliminate a variable, you're going to multiply by a different number. And that's something that we have to figure out on our own. I'm going to multiply the first one by 2, the second one by 3, equation A, equation B. Let's rewrite the equations with the distribution of both those factors. The new equation A is going to be 8x plus 6y equals negative 38. The new equation B, multiplying 3 to each term, is going to be 9x minus 6y equal to negative 30. I'm adding equation A and equation B together, the new equations. Sorry. So I'm going to get 17x equals negative 68. Divide both sides by 17. X equals negative 4. Substitute this negative 4 into equation A. It does not matter. So the original equation A, 4x plus 3y equals negative 19. 4 times negative 4 plus 3y equals negative 19. I get negative 16 plus 3y equals negative 19. Add 16 to both sides. 3y equals 3. Negative 3, excuse me. Divide both sides by 3. Y equals negative 1. My solution is going to be negative 4, negative 1. See you in class.